This is the lecture number 11. Today we are just talking about the master theorem. My suggestion to everyone, before coming in this lecture, you must go in the previous lecture, that is the lecture number 10. We are just talking about the space complexity and time complexity. We have already discussed on the big O method and the theta method and omega method. Okay, what is the meaning of time complexity? Why we are using this one? Okay. So now today, whenever you have got any function, just like that function, Tn is equal to a t n upon b plus theta n ki power k log p power p n. Okay. So whenever you are getting such type of function, means suppose you have written any algorithm and the algorithm it is running n times, then you have got this recursion formula. Okay. So in this recursion formula, if you have such type of this form, then you will say that this is the master theorem you will apply. So there are some terms and conditions. First condition is a must be greater than equal to 1, b is greater than 1, k is greater than equal to 0, and p belong to real number. Okay. So whenever you have got this form, then after then there are three conditions. Okay. For the first condition, if you have first condition, then after then you can write directly the time complexity of such type of form. If a is greater than b ki power k, then you can write Tn, means time complexity is equal to theta n ki power log b base a. Okay. And if a is equal to b ki power k, in this condition there are three cases. Okay. The first case is if p is greater than -1, then time complexity Tn is equal to theta n ki power log b base a and log p plus 1, power p plus 1 n. If p is equal to -1, then Tn is equal to theta n ki power log b base a and log n. And the C condition, if p is less than -1, then Tn is equal to theta n ki power log b base a. And the third condition, if a is less than b ki power k. Okay. In this condition, you have two cases. The first case is if p is equal to greater than equal to 0, then Tn is equal to theta n ki power k log p power log to the power pn. And if p is less than 0, then Tn is equal to big O n ki power k. Okay. So you have such type of condition. Now we will discuss that. We are showing some example. What is the meaning of this? Okay. The first question we are showing you. The first question, that is very simple. Suppose you have this question. Okay. Suppose you have got this time complexity. Okay. The function you have got 16t n upon 4 plus n. Suppose you have this form. Okay. Now we are talking about this one. At first we will compare this function to this one. It is a master theorem or not? Now according to this, you can see that a is equal to 16 and b is equal to 4, and there is no log. So okay, so we can write log 0n, because x to the power 0 is equal to 1. So we can write log 0 to the power 0 n. It means that this is 1. Okay, this is indicating 1. So it means that you have p is equal to 0 and k is equal to 1. Okay. So now we will check the condition. A is greater than equal to 0. Yes. B is greater than 1. Yes. K is greater than equal to 0. Yes. And p belong to R. Yes. Now the first condition, we will check that it is holding this one, this one, this one. Okay. Which one? Now a is equal to 16. A is equal to 16. Okay. And is greater than b ki power k. K is 1. Okay. Yeah. It means that a is greater than b ki power k. It means that this condition is satisfying. It means that directly, whenever you have such type of form, you can write directly time complexity for such type of form. Tn is equal to theta n log b base a. B is 4. B is 4 base a. Base a means 4 to the square. 4 to the 16. And we know that log a base a n is equal to n. So after then, this will be Tn is equal to theta n to the power, this is square. So this is the time complexity for such type of form. Okay. So you know that if you have such type of form you have got, okay, by the help of recursion algorithm. After lecture this, in the lecture number 12, we will discuss on T. Okay. So then directly you can write the time complexity for such type of case is Tn is equal to theta n square. Okay. Now the second example. Okay. The second example we are talking. The second example. The second example is, suppose you have this Tn is equal to 6T n upon 3 plus n square log n. Suppose you have this. Okay. Now you can see that A is equal to 6, A is equal to 6, and B is equal to 3, B is equal to 3, and K is equal to 2, K is equal to 2, and log Pn, it means that there is 1, it means that P is equal to 1. Now you will check that A is greater than 1, yes, B is greater than 1, yes, K is greater than equal to 0, yes, and P belong to R, yes. Now which one is correct? Now A is equal to 6, A is equal to 6, now is, and this is 3 to the power square, 3 3 is 9, is equal to 9. You know that this is less than this. It means that A is less than B ki power k. Which one is this? This. Condition number 3 it is holding. Now P is equal to 1. P is equal to 1 means P is greater than equal to 0. Okay, the condition number first is satisfying. It means that your time complexity for such type of case is equal to theta n ki power k. K is equal to 2, and log P is equal to 1. P is equal to 1 log n. So your time complexity is Tn is equal to n square theta n square log n. Your time complexity is n square log n. Okay. Now I am taking third example. Very simple example I am taking. The third example is, suppose you have this form. Tn is equal to 2T n upon 2 plus n log n. Okay. Suppose you have this form. Now in this condition you can see that A is equal to 2. A is equal to 2. Okay. And B is equal to 2. And B is equal to 2. Okay. And n ki power k. It means that k is equal to 1. K is equal to 1. Okay. And log Pn. It means that P is equal to 1. P is equal to 1. Now we will check. A is greater than 1. Yes. B is greater than 1. Yes. K is greater than equal to 0. Yes. P belong to R. Yes. It means that all conditions satisfying. Now we will come here. So in this condition you can see that A is 2 is equal to 2 ki power 1. Okay. It means that A is equal to B ki power k. Now you can see that because k is equal to 1. So this condition is satisfying. Okay. For this condition you have to use anyone. Okay. You know that P is equal to 1. So P is greater than 1. It means that case number first will satisfy. P is greater than minus 1 because P is equal to 1. Okay. So directly you can say that the time complexity Tn is equal to theta n ki power log B base A. Log B base A means B is 2 and this is also 2 base 2 power 1. And after then log P plus 1. P is 1. P plus 1 it means that 1 plus 1 2 n. So your total time complexity it will be, now you have to use this formula, log A base A n is equal to n. So this is 1. So you can write theta n log square n. Okay, this is the final answer for such type of problem. So now we will discuss, I am just erasing it, we will discuss another question, then it will clear your concept. Now this time we have this question. Okay, this time A is equal to 2, A is equal to 2, B is equal to 2, B is equal to 2. Okay, now theta n, this is n upon log n. This is n upon log n. It means that you know that 1 upon x is equal to x to the power minus 1. It means that log, it means that you have log minus 1 n. Okay, in this condition the k, n ki power k is 1. Okay, k is 1. Okay, and this is negative. It means that p is equal to minus 1. Okay, so now A is greater than 1. Yes. B is greater than 1. Yes. K is greater than equal to 0. Yes. And P belong to R. Yes. Now which condition is satisfying? Now you can see again we have this case, because 2 is equal to 2 to the power 1, because k is 1. It means that A is equal to B to the power k. Okay, it is satisfying. Now P is equal to minus 1. P is equal to, this condition is satisfying. P is equal to minus 1. It implies that your time complexity for such type of case is equal to Tn is equal to theta n ki power log B base A. N ki power log B What is b? B is 2, base a is 2, power 1, okay, into log n, okay. This is the answer, final answer. Again we are using the same formula. The formula is this: log a base a ki power n is equal to n, okay. So in this condition this value will be 1. In this condition theta n ki power 1 and log n. This is the time complexity for such type of problem, okay. Now we are just discussing again another example, that is, let we have this formula, we have this problem. Tn is equal to 3t n upon 3 and plus n upon 2. Suppose you have this problem, okay. So now you can see that we will compare this. A is equal to 3, okay, b is equal to 3, okay. Now this is constant 1 upon 2, no problem. And n ki power 1, it means that k is equal to 1. There is no log, it means that p is equal to 0, okay. So in this condition your a is greater than equal to 1, yes. B is greater than 1, yes. K is greater than equal to 0, yes. P belong to R, yes. It means that which one is satisfying. Now we will check. A is equal to 3. 3 is equal to 3 ki power 1. It means that A is equal to B ki power k. This condition is satisfying again. But P is 0. P is greater than minus 1. It means that this condition is satisfying. Your time complexity Tn is equal to theta n ki power log B base A. Log 3 ki power log B base means log base 3 ki power 1 and log P0 log 1 n, okay. So your time complexity, this is 1, okay, theta n log n. This is the time complexity for such type of problem, okay. This is a master theorem. Again we are repeating. Now we will show you some important question. That important question, it has come in your GATE exam, okay. So I am erasing it. Now there are some examples, it has come in your previous year GATE. This is another question they have given you. Tn is equal to 2 ki power n, t n upon 2 plus n ki power n. Now at first you have to check that this is satisfying the master theorem or not. So now you can see that a is equal to, according to this, a is equal to 2 ki power n, okay, and b is equal to 2 and b is equal to 2, okay, and n ki power k. This is, it means that k is equal to n because of n ki power n, okay. There is no log, it means that you can say that p is equal to 0. The first one you must note that where a is greater than equal to 1, b is greater than 1, k is greater than equal to 0, p belong to real number. Now you must note that f is equal to me. At first we are talking about this. Why we are talking? Just we will talk. F is equal to me. You know that this is your earth, okay. In the earth, your mass, that is constant everywhere. Even your velocity, it is very fast. Okay, I am just not talking about the universe. I know that if you will go from here to another place with a c velocity, then your mass, that will be not unique in this condition. But here we are talking, if you are inside a earth, then in this condition your mass, it is unique. So mass is unique, it means that this is constant. Mass is constant. If your mass is constant, okay. Now this is totally depend on the conditions. If your vehicle speed, it is very fast, in this condition your acceleration, it will be increased, okay. Where if you are just taking brake, okay, you have just brake, okay, you brake in your vehicle, in this condition your it will decrease, okay. So this is sometimes increasing, sometimes decreasing, okay. Means this value, it is changing. It is depend on conditions, but it is not changing inside the earth, okay. Even you have any conditions, it will never change. So what is the difference between variable and constant? We are talking here. So this is a variable, okay. This is variable. You have seen that variable is changing. Variable is depend on conditions, okay. On the conditions, different conditions, the acceleration, it is changing, but the constant, it will be never change in any conditions, okay. So So this is the difference between variable and constant. So why we are just using the physics here? Because here these all are constant. These all are constant. But here we have written a is equal to 2 to the power n. If n is equal to 1, then your a, it will be 2. If n is equal to 2, then your a, it will be 2 to the power 2. If your a is equal to n is equal to 10, in this condition a is equal to 2 to the power 10 is equal to 1024 in this condition. So your a, it is also changing every time. Yeah, I know that is greater than 1. But on different conditions, your a is also changing. On different condition, your k is also changing. So these are the variables. These are not the constant. Okay, so I will say my suggestion to you, this is not satisfying the, sorry. This is not satisfying the master theorem. Okay, so this is not satisfying the master theorem. The first one. Now, the question number second. Question number second, they have given you Tn is equal to 64 T n upon 8 minus n square log n. Now you can see that our master theorem, that is totally depend on the positive function. This is a positive function actually. So you can see that this is also positive and this is also positive. This is a positive function. This is not a negative function. You cannot see negative anywhere. But here is negative. So this is also not satisfying the master theorem condition. Okay. So this is, it will not applicable. You have to solve this by another method. We will just discuss on such type of question in the lecture number 12. Now here, this is the question number 3. In the question number 3, they have given us Tn is equal to 0.5 T n upon 2 plus 1 upon n. Now, what about 1 upon x? 1 upon x, you can write x to power minus 1. It means that if you are just writing like this, in this condition you have this, okay. It means that n k power k, it means that k is equal to minus 1. But we have written k must be greater than equal to 0. So, this is not satisfying master theorem. Okay. So, you cannot apply such type of cases. Okay, now the last question here, they have given us Tn is equal to 2. 2 means A is equal to 2. Okay, and here B is equal to 4. B is equal to 4. Okay, plus theta n ki power k. K is equal to 0.51. Don't think that here they have given us 0. Float value. It means that we cannot apply the master theorem. We can apply because k is greater than equal to 0. K is not greater than 1. They have not written k is greater than 1. They have written k is greater than equal to 0. In this condition it is satisfying. But p is 0 because near there is no log. Okay. In this condition your case is satisfying. So master theorem it will be applied for case number 4. Now we will check for which condition it will satisfy. The first one they have given us a is greater than b ki power k. What is a? 2 is greater than 4 ki power 0.51. It can possible? We have to check it. At first, you have to check it that it is satisfying. No, that is not satisfying. 2 is not greater than this. Okay. Now a is 2. 2 is less than b ki power 0.51. Yes, this is correct. So this condition is satisfying. P is greater than this. So your time complexity Tn is equal to theta n ki power k. K is 0.51 and log p is 0. Okay, this is your time complexity n ki power 0.51 for condition number 4. Okay, so in the GATE exam also they will give you such type of form and they will ask that what is the time complexity. There will be 4 options and you have to tick on one option. Okay, so this is the necessary condition. You have to remember. If you will solve a lot of questions, okay, on the basis of this condition, then you can qualify the GATE exam. Okay, also this is also very important. If you are just studying in B.Tech, okay, they also ask such type of questions. And if you are studying in also IIT, you are completing the data structure course, and this is also very important. They also ask in your examination such type of question. Okay, I think that you understand already. We have given you 10 examples. That is sufficient to learn. Okay, if you are facing any problem, then you must write in the comment box, and I will give you the other best lectures for such cases. Thank you so much.